right?
Yes, sir.
So are you writing, all of you? Some heat energy is lost
Lost it, sir.
in surroundings. Okay, this is first point. And second point is uh, you have to understand the diagram first, and you have to also understand one thing that in our surrounding area, if the temperature is more, like our room temperature is 30 degrees Celsius, okay, and the temperature of the hot body or the object which one is very hot, that temperature is 50 degree. Okay, then you are having the rate of change of temperature or the heat loss, um, and if the temperature of the hot body is 80 degree, how much it is? Hello, are you understanding what I am saying? I am showing you with diagram, then you understand more. Look, uh, our room temperature is how much? 30
30
degree.
degree.
Okay, 30 degree. 30 degrees Celsius. You can also take these notes. It is very important. Now we are having one hot object of 50 degrees Celsius. Okay, 50 degrees Celsius. So this hot object will lose heat to surroundings until it reaches to room temperature, right? Isn't it? Hello?
Yes, sir.
The hot things always lose heat to the cold things, isn't it?
Yes, sir.
Okay, then if you are getting another hot object like this one, you have 80 degrees Celsius. So the way the 50 degrees Celsius object is losing heat, I am talking about the rate. Like in 1 second, if it is losing the heat energy 1 joule, and this 80 degree will lose more faster, right? It will lose more heat in 1 second, isn't it? Hello? Hello?
Yes, sir.
Do you understand what I am saying?
No, sir.
Okay, try to understand. I am explaining again, no problem. Uh, if you are given two objects, one is 50 degrees Celsius and another one is 80 degrees Celsius, then which one will lose more heat? 80 degrees Celsius or 50 degrees Celsius?
80 degrees Celsius.
Salam, sir.
Walaikum salam. 80 degrees Celsius will lose heat more faster, right? The one,
Yes, sir.
the difference of this 30 degree and 50 degree, it is 20 degree only, but 80 degree and 30 degree, the difference is 50 degrees
50
Celsius.
degree.
So 80 degree one will lose heat more faster, right? Isn't it?
Yes, sir.
And you
Yeah.
see in our graph, we have the temperature at the beginning 24 degree, then we have 40 degrees, 60 degree, 80 degree, then at last we have 100 degree. So at the more higher temperature, faster loss of thermal energy in the surroundings. Is it clear now? That's
Yes,
why
sir.
here we are getting the line not straight. If always the rate is same, then we will get straight line. But the more temperature we have, the rate of the temperature lost will be faster. That's why we are getting here curved line. Is it clear now? Hello? Hello? Sad, is it clear?
Sir, I
Kajizawa?
didn't get it, sir. I
Yeah,
came late, sir. That's why.
yeah, you came late. What about others? They who were present? Faiza, then
স্যার সব
Zawad.
মাথার উপর দিয়ে গেতেছে স্যার,
Okay, I will
কিচ্ছু
make
বুঝতেছে না।
understand. No problem. I am explaining from the beginning. No problem. I am going down. Here we have. Okay. For example, in your house, you have two glasses of water. Okay, or 2 cups of tea. Clear?
Yes, sir.
Are you understanding what I'm saying? In your house, we have, for example, we are taking teas. That one we are talking about. We have 2 cups of tea. Okay, 2 cups of tea. Now, one of the cups temperature is 50 degree, and another cup has 80 degrees Celsius. Is it clear? Of
Yes, sir.
50 degrees Celsius, 50 degrees Celsius, and 80 degrees Celsius. Okay. Now, you two friends are observing the temperature with thermometer. Huh? That which one is losing heat faster, the 50-degree cup one or the 80-degree one? For example, your room temperature is 30 degree. So you are taking the reading for 5 seconds. How many seconds? Hello?
5 seconds.
You are taking the reading for 5 seconds. Okay, you write here that 5 seconds. Okay, after 5 seconds, you are observing that 50-degree one, that one is reaching 40 degrees Celsius. Okay, and the 80-degree one, that one is reaching 50 degrees Celsius. Is it clear now? Hello? Whatever I am writing, are you writing?
Sir, but how the 50-degree cup?
The 50-degree
Yes,
and
sir. But
30
I have a
degree,
question, sir.
you see the room
Sir.
temperature is 30 degrees Celsius, right? And your temperature of
Yes,
two
sir.
cup of tea is one is 50 degree, another one is 80 degrees Celsius. So it is the property of the hot objects that which one is having more temperature, that one is losing heat more faster. Is it clear?
Yes, sir.
So the 50-degree one in 5 seconds is losing how much?
10 degree.
Yeah, it's losing 10 degrees Celsius. And the 80-degree one, how much it's losing?
30, sir.
30 degree it's losing. So who is losing more? 80-degree one, right? 80-degree one is losing more heat, right? In one
Yes, sir.
second. So if you divide it by 5 seconds, you are dividing it by 5 seconds. How much is coming? 10 divided by 5, how much it is the rate? 2 uh, degrees Celsius every second, right? And 30-degree one, if it is losing in 5 seconds, then to divide by 5 seconds, I am finding the rate. The way you are finding the speed, that one. 30 divided by 5, how much it is? 6, right? Then 6 Celsius per second. So which one is losing faster? Hello? This 6 degrees Celsius per second is lost by the 80-degree one, and 2 degrees Celsius per second is lost by 50-degree Celsius cup one. So who is losing faster? Hello, Saad.
Sir,
Yes,
the
sir.
80-degree cup.
50 degree, 80 degree one, sir. 80 degree one.
Now it's clear to you.
Yes, sir.
Now, if it is clear, then take all these notes. And the sum I am writing. Here is the note that at
Okay, sir.
higher temperature, HIGH, higher temperature, the rate of loss of energy is more.
The rate of losing energy. No, sir.
Okay, you're right. Losing energy, right?
And sir, another, sir.
Rate of loss of energy, right?
No, sir. Sir, another. This is the like explain why temperature increases in this way, or like this is the
Yeah, because
another
we
thing.
are not getting straight line. Why we are not getting straight line? Because at higher temperature, the rate of loss of energy is more. At lower temperature, it is less. That's why we are not getting always the same rate. Is it clear?
Yes, sir.
So take all these notes, because if you are taking these notes, then you can remember it easily. And here you write beside 30 degree, it is room temperature. Okay. I'm writing also this one here. For this one, we are getting these two, right? We have cups of tea, 50 degrees Celsius and 80 degrees Celsius. So this one we are getting from here, and this one is room temperature. You take this note. This is room temperature is 30 degrees Celsius. That it will be more, clear to you. Room temperature. Okay.
Yes, sir.
Now we have the last part. If you are done with this, everyone tell me. Are you done with this?
Yes,
Hello.
sir.
Then Farabi, you understood it. Aisha, Adnan Rahim,
Yes, sir, I
Faizal,
understood, sir.
Dawad, Rabi, did you understand this discussion? That at higher temperature, the rate of loss of energy is more.
Yes, sir.
Okay, very.
Yes.
So are you taking these notes? And here we are in 4B2. 4B2, we had these points, all these discussions. Yesterday we discussed till 4B1. Now we are continuing next part. If you all are done, then we are going to next part. C. Okay, Rabi, you
Sir, I have a
continue C.
question, sir.
Yes, sure, sure.
Sir, 5 seconds, 40 degrees Celsius and 50 degrees Celsius. Then, sir, again, sir, 10 degree divided by 5. Or it is random or like from this question.
Like I gave you one example. It will not be always same. Like the room temperature, if it is changed, if the body temperature of the hot object, it is different. It might be different, right? One thing we understand. that if the temperature of the hot object is more, then the rate of loss will be faster. This thing at least you understand, right?
Yes, sir.
And if it is so, then we will never get a straight line. Is it clear?
Yes, sir.
Okay. Any more questions?
No, sir.
Okay. Thank you. Now, next part. C. Ravi, you continue this. C. Oh, Ravi is not here. Ravi left.
When the temperature reaches 100 degrees Celsius, the kettle is left on the burner. The thermal energy is still supplied to the water. The water boils as the molecules form bubbles and rises the surface. State what happens to the temperature of the water.
Yes. When the temperature reaches 100 degrees Celsius, the kettle is left on the burner. Thermal energy is still supplied to the water. The water boils as the molecules form bubbles and rise to the surface. State what happens to the temperature of the water. The water temperature cannot be more than 100 degrees Celsius. If it is more than 100 degrees Celsius, it will be vapor, right? Isn't it?
Yes, sir.
So, as they are asking about water only, so our answer will be it will remain 100 degrees Celsius or it will remain constant. Is it clear now? Hello?
Yes, sir.
The temperature of water remains 100 degrees Celsius. If they are asking about the vapor, not the water, then what will be the answer?
So the temperature of vapor is higher than 100 degrees Celsius.
Yes, it will be higher than 100 degrees Celsius because it is possible. But the water, as it is still water, it will be 100 degrees Celsius only. Okay? Because it is
Yes, sir.
boiling. That means it is at boiling point. So is it clear now?
Yeah.
Okay, now we are going to next part. Yeah. Farabi. Hello, Farabi. Farabi.
Yes, sir.
Farabi, can you read please this part?
Explain in terms of the molecules why it is necessary to supply thermal energy in order to keep the water boiling.
Okay. Why it is necessary to supply thermal energy in order to keep the water boiling? In our one of the examples, you see, we yesterday discussed one of the examples about gold. Can you remember that one? This one. Can you remember this? That they are asking you explain in terms of molecules why thermal energy is needed to melt the gold. So that time we had liquid from solid, right? We had liquid from solid. So what was the answer yesterday for this one? Why we needed thermal energy to melt the gold? Can you see from your notes? Hello,
To break the
read it loudly, please. Loudly and slowly so that everyone can understand.
that to break the structure of solid, we need to do some work. That's why thermology.
So here we are also using the same idea. Like in that case, we had solid and we got liquid. That means breaking the breaking of the bond from solid to liquid. To do this, we had to do some work, right? Isn't it? And for that reason, we needed some thermal energy to do that work done. Similar way, here we are having from liquid to gas, right? In it was in liquid form. You see, in terms of the molecules, why it is necessary to supply thermal energy in order to keep the water boiling. So during boiling process, we get from liquid to gas, right? During, you write it, during boiling, we get gas from liquid. So structure of liquid and structure of gas, you know, right? In liquid, they are closer, right? They are sliding over each other. But the gas molecules, they are very far apart, right? Isn't it? Hello? Hello? To break the bonding of liquid to get gas, we need to do some work. We need to do some work. Now I'm writing the last point. That's why we need thermal energy during boiling. So are you writing these points? Hello? Mohammad Saad, are you writing? Adnan Rahim?
Yes,
Aisha,
sir.
Nusrat, Rabi,
Yes, sir, I'm
Shafqat,
writing.
Shafqat, are you
Yes,
writing?
sir.
So write it please. These 3 points you have to write for this explanation. Why we need energy? Because we have to do some work, break the bonding, convert from liquid to gas. And you check out, yesterday Faiza was present, then Saad, Arabi, they were present, and you check out that our previous discussion and the discussion going on now, they are matching. You should link. Okay, if you are linking more, then you do not need to take hassle, or you do not need to give so much effort for memorizing. Okay, so if you are done, then we can go to question number 5. Are you done?
No, sir.
Once you are done, then you tell me. Then we can go to next question. Can we go to next question? Shafkat,
Yes, sir.
Aisha, Rabi, Adnan Rahim, Farabi, Saad, Nubrat. Are you done with writing?
Yes, sir.
Nubrat is not talking. She is only
Yes,
joining.
sir. I'm done. I'm done.
Yes, yes. Thank you. Then you continue, Nubrat, from here. 5. Question 5, continue.
Okay. Airplanes fly at high altitudes where the temperature is well below 0 degrees Celsius. Ice that forms on an airplane can fall to earth and strike the ground. Figure 5.1 shows a block of ice falling from an airplane as it approaches an airport. The mass of the falling block of ice is 1.2 kg and the gravitational field strength G is 10 Newton by kg. Calculate the weight of the block of ice.
Okay, tell me the weight. You calculate and tell me, Nubrat.
12 kg, 12 kg.
Wait. Let her say why you are saying.
Because I know the
Nubrat,
answer.
Nubrat,
Yes, sir?
what is the weight?
Sir, give me 2 seconds. They'll tell you the answer right away.
Yeah, what is the formula of weight? Can you write the formula? I'm writing here. W
Sir, I
equals
cannot see. Oh, yeah. Yeah. W
W
equals to
equals
M.
mg. M for mass, right? What is the mass?
The mass is 1.2 kg.
Then we have gravitational field strength, right? Given G,
10 Newton per
Yeah,
kg.
10 Newton per kg.
per kg.
We did it in class 8, right?
Yes, sir.
Then kg cut.
Yeah,
What is the unit of weight?
sir. That is what it is.
If kg cut, then we have Newton left, right? Then it is 12 Newton.
12 Newton.
Yeah, please write the unit correctly. Mohammad Saad,
Yes, sir. I know, sir.
the unit
12
is
Newton, sir.
12 Newton. Very good. Then our next part of the question, this one. Continue, Nubrat, continue here. Part B.
Which one? At the first acceleration
Yes.
or?
B.
Okay.
Figure 5.2.
Oh. Figure 5.2 is a speed limit graph for the block of ice as it falls to the ground. At first, the acceleration of the block of ice is equal to the acceleration of free fall. The acceleration of the block then decreases to zero as the block reaches terminal velocity. As the block of ice falls, the force F of air resistance acting on the block changes. Number 1. State the value of F at the time is equal to 0.
The acceleration of free fall, sir.
Yes, state the value of F at time 0 and at time 10 seconds. You have to find it. Now,
Sir. What is the terminal, sir? What is the acceleration of free fall, sir?
acceleration of free fall is 10. 10 Newton per kg you got. That one is 10 meter per second square. That's it.
Nah, sir, what is it actually, sir?
It is because of uh, the environment is air free. There is no air resistance is working. That's why we are getting acceleration of free fall. If you are,
There will be always. It will
yeah,
be always, right, sir?
yes, it will be always 10 meter per second square. Okay.
Yes, sir.
Look, this diagram is related to kinematics, right? Then we have also brought the idea of dynamics. In thermal physics, we are having the idea of previous ideas, previous chapters, previous topics, right? So you should link the previous idea with present idea. Now they are saying as the block of ice falls, the force F of air resistance acting on the block changes. State the value of F at time t equals 0. So at the beginning, you are playing football, okay? So during playing football, if you are staying in one place, you did not start the run. That time, are you facing any air resistance?
No.
You are not facing any air resistance. So at the beginning, we are having here a straight line. You see that one is constant, almost constant, right? So you
Yes.
see the acceleration, if we are getting this way straight line, steeper straight line for speed time graph, that means your acceleration is constant. And that acceleration is coming from acceleration of free fall. That is 10 meter per second square. Is it clear? Hello? So
Yes,
this
sir.
part of the graph we are having acceleration of free fall. Everyone take the notes. If there is steeper straight line for speed time graph, we are having constant acceleration, and that is acceleration of free fall. So at time t equals 0, the value of air resistance is not started working. It will be 0, right?
Yes, sir. 0 meter per second square.
Okay, then after 10 seconds, it is reaching here. And here we are having constant speed, right?
Yes, sir.
You see we are getting a straight line horizontal to time axis, parallel to time axis. So we are having here constant speed. Time is increasing but distance remains same. It's constant speed. If the constant speed is there, then there is no acceleration, right? Here we are having,
Yes, sir.
please take these notes. At terminal velocity a equals 0. Take these notes. We are discussing question number 5. 5b. So at terminal velocity our acceleration is 0. Okay. So acceleration 0 means what? Resultant force also 0, right? We have this formula
Yes,
F
sir.
equals ma, right? Here F is the resultant force according to Newton's second law. So if A is 0, that means F is also 0, right? Resultant force is 0.
Yes, sir.
This F is different. This F is for resultant force. Okay, not this F. They are marking this F as air resistance. Look. Okay, so if resultant force is 0, that means your weight and air resistance are equal, right? Please take these notes. You also know this from your weight is working downwards, right?
Yes, sir.
And air resistance is working on the ice upwards. This is air resistance. Take these notes, everyone.
Yes, sir.
And both these forces are equal and opposite. So according to Newton's first law, the object will be in constant speed or terminal velocity, right? Air resistance. So at time 10 equals 0, air resistance is equal to weight. What was the value of weight? Can you remember?
12. Sir, 12 Newton.
12 Newton. Only you know. What about others? They don't know. Air resistance and weight are equal and opposite. That's why our resultant force is 0. So we can write
Sir,
here,
can you explain it, sir? So can you explain it again, sir, from the beginning, sir?
yes, I'm explaining it. Uh, till here you understood, right?
No,
State
sir.
the state the value of F, the air resistance at time t equals 0. You understood it, right?
Yes, sir. Up
Because
to that.
yeah, air resistance is zero. I gave you one example. Like you started running, uh, you are stopped, but you did not start running during playing. Then you are not feeling any air resistance, right? That time we are having acceleration constant, right? So
Yes, sir.
the air resistance is zero that time. Now after this, air resistance starts working, right? The more air resistance working, the lower the acceleration we are getting. You see, we are having here graph, right? Curve. The acceleration is decreasing. The resultant force becoming smaller and smaller. What is resultant force? Can you tell me? Resultant force means the subtraction of weight and air resistance. At the beginning, weight is more, right? And the air resistance is less, isn't it? Hello?
Yes, sir. Hello.
That's why if the weight is more, air resistance is less. That's why the resultant force was greater before. Now the resultant force is decreasing as the air resistance is increasing. That's why we have here curve line. You see, A is decreasing, right?
Yes, sir.
So A is decreasing, and at this point, the weight and air resistance becomes equal. That means resultant force is zero, isn't it?
Why, sir? Why, sir?
Because weight and air resistance is equal. Then if you are subtracting, then your resultant force will be zero, right?
How it is equal, sir? How it is equal, and how the result? What is, sir? How what is
Okay,
resultant?
okay, very good question. In our next class, we will continue it, okay?
Okay, sir. From the beginning, sir. Again, sir.
Okay, you take this screenshot, huh? Then